Welcome to qnawire.
Question we have Q1 equals to 2 microcoulomb without its charge nature, and Q3 is equals to plus 4.00 microcoulomb. Its nature is known. Okay, so and the net force is towards the left, that is in negative x-axis. So for the part A of the question, we have to sketch all the possible outcomes depending on the sign of the charges. So this is charge Q1, this is charge Q2, and this is charge say Q3. This is Q1, Q2, and this is Q3. Okay, so now we can take it as positive, and it is also positive, and this is given as positive. So the force due to this charge on this will be in this direction, and due to this charge the force will be in this direction. Okay, so say this is F1 force and this is F2 force. So this is situation 1. Okay, now the situation 2 will be, this is Q3 charge, this is Q1 charge, and this is Q2 charge. So let's, its sign is negative and its sign is negative, and it is already positive, so the force will be in these directions. So this is force F1 and this is force F2. Okay, now for the, this is situation 2. So now for the third situation we can draw that this is Q3 charge, this is Q1 charge, and this is Q2 charge. So let us take it as positive and it's negative, and it is given as positive. So the force due to this charge on this will be in this direction away. Okay, and this force will be in this direction. So this is say force F2 and this is say force F3, F1. Okay, so this is situation 3rd. Okay, now the situation 4th will be, this is Q3, Q1, and Q2. So let us take, it is negative, it is positive, and this is positive as per the question. So the force due to this negative charge on this will be along this direction, and the force due to these two positive charges will be repulsive. So this is force F2 and this is say force F1. Okay, so these are the 4 possible outcomes of the question. Okay, so this is the 4 possible outcomes of the question. Okay, now moving to the part B, in which we have to determine the nature of the charge Q2 according to the problem. So for the part A, we can say that the force will be in the upward direction and towards right direction, because the forces are in the left and right direction. And for the situation 2, the force may be in the downward direction, and also in the horizontal forces may cancel out. Okay, so for the situation 3rd, the net force may comes out in the right direction, and the vertical force may cancel out. Okay, because if the magnitude somehow changes or rearrange itself, so may cancel. So for the 4th situation, the force may be towards left and the vertical force may be cancel out. Okay, so the 4th situation is the required situation. So we can say that Q1 should be negative. Q1 is given as negative charge. Okay, and Q2 should be positive. Okay, this is the outcome of the question. Okay, Q3 is given as positive already, and Q1 should be negative and Q2 should be positive, so that we get net force in the left direction. Okay, so we can say that Q1 is equals to, as we have magnitude of Q1, so we can write that Q1 is equals to minus 2.00 microcoulomb, and Q3 is equals to plus 4.00 microcoulomb, and we can say that Q2 is greater than 0. So this is the answer for the part B of the problem. Okay, Q1 is negative and Q2 is positive. Okay, so now moving to the part C, in which we will determine the magnitude of charge Q2. Okay, so in this part we have determined only its sign. So the case 4th is the right one. So the vertical force must be equal in magnitude and opposite in direction. So we can write that angle theta1 of force F1 and horizontal is cos inverse of 4 by 5 from the geometry. So it is equals to 36.86 degree. And angle theta 2 between F2 and horizontal is equals to cos inverse of 3 by 5. This is equals to 53.13 degree. Okay, the vertical force must be equal, so we can write that F1 cos 36.86 degree, this is equals to F2 sine 53.13 degree. Okay, say this is our equation number 1. So now the force F1 can be written as F1 equals to K Q1 Q3 divided by R13 square. So substituting values, we get 9 multiplied by 9, 9 into 10 to the power 9 multiplied by Q1 charge is 2 multiplied by 10 to the power minus 6, and Q3 is 4 into 10 to the power minus 6. So now we will consider magnitudes only, and R13 is 0.04 so square. So from here we get F1 equals to 45 Newton. Okay, and from here substituting this value in previous one equation, so we get F2 equals to 45 multiplied by sine 36.86 divided by sine 53. Okay, so from here after solving we get F2 equals to 33.8 Newton. Now F2 can also be written as F2 equals to K Q2 Q3 divided by R23 square. So now substituting values, K is 9 into 10 to the power 9, and Q2 multiplied by Q3 is equals to 4 into 10 to the power minus 6 divided by R23 is 0.03 meter so square. Okay, and F2 has magnitude of 33.8 Newton. Okay, so from here after solving we get Q2 equals to 8.43 multiplied by 10 to the power minus 7 coulomb, which is equals to 0.843 microcoulomb. Okay, so this is the answer for the question. Okay, as Q2 is positive, so its magnitude will be in the positive. Okay, so this is the answer for the part C of the problem. Now for the part D, the magnitude of net force will be equals to F1 cos 36.86 degree plus F2 cos 53.13 degree. Okay, so now after substituting values of F1 and F2, from here F1 is 45 and F2 is 33.8, we get 45 cos 36.86 degree plus 33.8 cos 53.13 degree. So from here after solving we get F equals to 56.2 Newton. Okay, so this is the answer for the part D of the problem. This is the net force on the charge Q3. Okay.